Hi everyone, welcome back. In this video, we are going to cover the top 100 Python interview questions and answers that are most frequently asked in real interviews. Whether you are a beginner, a Python developer, or preparing for software engineering interviews, this video will help you strengthen your Python fundamentals and improve your confidence. Let's get started. What is Python and why is it so popular? Python is a high-level, general-purpose programming language. It was designed to be simple, readable, and easy to use. A beginner can start writing Python code quickly, but at the same time, large companies also use Python in production systems. Python is called a general-purpose language because it can be used in many different areas. For example, developers use Python for web development, automation, scripting, data analysis, machine learning, artificial intelligence, testing, DevOps tasks, cybersecurity tools, and even desktop applications. One major reason Python is popular is its clean syntax. Compared to many other languages, Python code is shorter and easier to read. That improves developer productivity because we can write less code and still build powerful applications. Another reason is its huge ecosystem. Python has a very large number of libraries and frameworks. For web development, people use Django and Flask. For data work, they use NumPy and Pandas. For machine learning, they use TensorFlow, scikit-learn, and PyTorch. Python also has a very strong community. That means there are many tutorials, open source libraries, forums, and learning resources available. This makes problem solving easier for both beginners and experienced developers. In interviews, a strong answer should not stop at saying Python is easy. You should say that Python is popular because it combines simplicity, readability, versatility, fast development, strong community support, and a rich ecosystem of libraries. That is why it is used by startups, enterprises, researchers, automation engineers, and data professionals. Next question. What are the key features of Python? Python has many important features that make it practical for real-world software development. The first key feature is readability. Python code looks clean and is often close to natural English. Because of that, code becomes easier to write, review, maintain, and debug. The second important feature is simplicity. Python removes much of the extra syntax that many other languages require. This helps developers focus more on solving business problems instead of fighting language complexity. Another feature is that Python is interpreted in normal usage. We usually run Python code directly through the interpreter without a separate manual compile step in the common workflow. This makes development and testing faster. Python is also dynamically typed. We do not usually declare variable types explicitly. The type is determined at runtime based on the assigned value. This gives flexibility, although developers must write clear and careful code to avoid runtime issues. Python supports multiple programming paradigms. It supports procedural programming, object-oriented programming, and functional programming. This flexibility is very useful in different project types. Another major feature is portability. Python code can usually run on Windows, Linux, and Mac with little or no change. It also has a large standard library. This is often called Python's batteries included approach. It means many common tasks such as file handling, JSON processing, regular expressions, date and time handling, and networking are already supported. In interviews, a complete answer should mention readability, simplicity, dynamic typing, interpreted nature, portability, support for multiple paradigms, rich standard library, and huge third-party ecosystem. That shows you understand why Python is practical in both learning and production environments. Next question. Is Python interpreted or compiled? Explain properly. This is a very common interview question, and the best answer is a balanced one. If someone says Python is only interpreted, that answer is too simple. If someone says Python is compiled like C or C++, that is also misleading. The correct explanation is this. Python source code is first compiled into bytecode. That bytecode is then executed by the Python virtual machine, which is part of the interpreter environment. So from a practical developer point of view, Python is generally called an interpreted language because we normally run the code through the Python interpreter. We do not usually create a separate native executable in the same way as languages like C or C++. Internally, when Python runs a program, it converts the source code into bytecode files. These are lower level instructions that the Python virtual machine can execute. That means Python does include a compilation step, but it is not the same as compiling directly into machine code. This is why the most accurate answer is that Python is compiled to bytecode and then interpreted by the Python virtual machine. In interviews, you can also mention the practical difference between compiled and interpreted languages. Compiled languages typically translate code into machine code before execution. Interpreted languages usually execute code through a runtime interpreter. Python sits in between in the sense that it uses both ideas, but in day-to-day discussion it is generally classified as interpreted. A strong interview answer should say this clearly. Python is not purely interpreted in the simplest sense. It is first compiled to bytecode, and then that bytecode is executed by the interpreter. That answer is accurate and shows deeper understanding than a one-line reply. Next question. What are variables in Python? Do we need to declare their types? A variable in Python is a name that refers to an object or value in memory. We use variables to store and work with data inside a program. For example, a variable can store a number, a string, a list, a dictionary, or even a function or class instance. One important interview point is this. In Python, variables do not store fixed data types in the same way many beginners imagine. A variable is actually a reference to an object. The object has a type and the variable name points to that object. Python is dynamically typed. That means we do not need to declare variable types explicitly in most cases. The interpreter determines the type at runtime based on the value assigned. For example, if a variable is assigned a whole number, Python treats it as an integer. If another variable is assigned text, Python treats it as a string. So the programmer usually writes the variable name and assigns the value directly. Another important point is that Python allows reassignment. A variable name can later refer to a different object. This gives flexibility, but it also means developers must write a readable code with meaningful variable names. In modern Python, we can also use type hints. Type hints improve readability and tooling support, but they are not strict type declarations in the same way as languages like Java. Python still remains dynamically typed at runtime unless special tools are used for checking. In interviews, a complete answer is this. Python variables are references to objects. We do not usually declare their types explicitly because Python is dynamically typed. The type is associated with the object, not permanently with the variable name. Next question. What are the built-in data types in Python? Explain them clearly. Python provides several built-in data types, and this is one of the most basic but important interview questions. A good answer should not only list the types, but also explain how they are grouped and used. First, we have numeric types. These include integer, floating point, and complex numbers. Integers are whole numbers. Floating point numbers are decimal values. Complex numbers are used when a real and imaginary part is needed. Next we have the Boolean type. A Boolean value is either true or false. This is commonly used in conditions, comparisons, and control flow. Then we have strings. A string represents text data. Strings are immutable in Python, which means their contents cannot be changed in place after creation. Now let us discuss collection types. A list is ordered mutable and allows duplicate values. A tuple is ordered, allows duplicates, but is immutable. A set is unordered, mutable, and stores only unique elements. A dictionary stores data as key value pairs, and keys must be unique. Python also includes a range, bytes, byte array, frozen set, and none type. Range is used for sequences of numbers, usually in loops. Bytes and byte array are used for binary data. Frozen set is an immutable version of a set. None represents the absence of a value. In interviews, it is also useful to mention mutability. Lists, sets, dictionaries, and byte array are mutable. Strings, tuples, frozen sets, bytes, integers, and floats are immutable. A strong answer should explain categories, examples, and mutability. That makes your answer look complete and interview ready. Next question. What are keywords in Python? Keywords in Python are reserved words that already have a special meaning in the language. Because they are reserved, we cannot use them as variable names, function names, class names, or identifiers in our program. For example, words like if, else for, while, class, def, return, import, try, except, true, false, and none are all Python keywords. Each of these words has a fixed purpose in the language's syntax. That is why Python treats them differently from normal user-defined names. A very common interview point is this. Keywords are part of the grammar of Python. They help Python understand the structure and flow of the program. For example, if is used for decision making, def is used to define functions, class is used to define classes, and return is used to send a value back from a function. Another important point is that the list of keywords can change slightly across Python versions. So in a real project, if we want to check the exact list, Python provides a built-in way to see them. But in interviews, you usually do not need to memorize every keyword. You just need to understand what keywords are and why they are reserved. A strong interview answer should also mention the practical rule. Since keywords have predefined meaning, using them as identifiers will produce a syntax error. That is why naming conventions are important when writing Python code. So the complete answer is this. Keywords in Python are reserved words with special meaning in the language syntax. They are used to define structure, control flow, logic, and declarations, and they cannot be used as normal identifiers. Next question. What are identifiers in Python and what are the rules for naming them? Identifiers in Python are the names we give to program elements such as variables, functions, classes, modules, and objects. In simple words, whenever we create our own name in Python code, that name is called an identifier. For example, if we create a variable for age, a function for calculation, or a class for employee data, all these user-defined names are identifiers. Python has some rules for identifiers. An identifier can contain letters, digits, and underscore. But it cannot start with a digit. It must begin with a letter or an underscore. Also, identifiers are case sensitive in Python. That means name, and name are treated as different identifiers. Another important rule is that identifiers cannot be Python keywords. For example, we cannot name a variable if or class, because those words are already reserved by the language. In interviews, do not stop only with rules. Also mention naming conventions. In Python, variable names and function names usually follow snake underscore case. Class names usually follow Pascal case. Constants are commonly written in uppercase style with underscores. This makes code more readable and more professional. Technically, Python may allow many names, but good developers follow clean naming standards so that the code is easier to understand and maintain. So the full interview answer is this. Identifiers are user-defined names for variables, functions, classes, and other program elements. They must follow Python naming rules, must not be keywords or case sensitive, and should follow standard naming conventions for readability. Next question. How do input and output work in Python? Input and output are basic operations in every programming language, and Python provides very simple built-in support for both. Input means taking data from the user, a file, a network, or another source. Output means displaying or sending data to the screen, a file, or another destination. In beginner-level Python programs, input is commonly taken using the input function. This function reads data from the user as text. That means whatever the user enters is returned as a string by default. This is a very important interview point because many beginners forget it. So if we want a number from the user, we usually convert the input into int or float depending on the need. Otherwise, Python will treat the entered value as a string. For output, Python commonly uses the print function. This function displays the result on the console. It can print text, variables, expressions, and formatted output. In interviews, it is also good to mention that Python supports formatted output using approaches like fstrings, format method, and older formatting styles. Among these, fstrings are widely preferred because they are readable and convenient. A slightly stronger answer can also mention that input and output are not limited to the console. Python can read from files, APIs, databases, and command line arguments, and can write output to files, logs, or network responses. But in a basic interview question, console input and output are usually the main expectation. So the complete answer is this. Python takes input mainly through functions like input and displays output mainly through print. The important detail is that input returns a string by default, so type conversion is often needed before doing numeric operations. Next question. What are comments in Python and why are they important? Comments in Python are lines in the code that are meant for humans, not for program execution. The Python interpreter ignores comments while running the program. Their main purpose is to improve readability and explain the logic of the code. Python supports single-line comments using the hash symbol. Anything written after that symbol on the same line is treated as a comment. For multi-line explanation, developers often use multiple single-line comments together. Sometimes triple-quoted strings are also seen for documentation like text, but technically those are string literals, not true comment syntax. This is a nice interview point because many people confuse multi-line strings with actual comments. Comments are important because they make the code easier to understand. They help other developers know why a certain logic was written. They are also useful when revisiting old code after some time. But in interviews, it is equally important to say this. Good code should not depend on too many comments. If the code is written clearly with proper naming and clean structure, comments should only explain intent, assumptions, edge cases, or complex business rules. They should not repeat obvious code. You can also mention docstrings. Docstrings are special string literals placed inside functions, classes, and modules to describe their purpose. They are not the same as normal comments because Python can access them at runtime. So the complete interview answer is this. Comments are non-executable notes in Python used to improve readability and explain logic. They are important for maintainability, but they should be meaningful and not replace clean coding practices. Next question. What is type conversion in Python? Explain implicit and explicit conversion. Type conversion means changing a value from one data type to another. This is very common in Python because programs often receive one type of data and need to use it in another form. For example, user input usually comes as a string, but we may need to convert it into an integer before performing calculations. Python supports two broad types of conversion. The first is implicit type conversion. This happens automatically when Python converts one type into another in a safe and logical way. For example, when an integer and a floating point number are used together in an expression, Python may convert the integer to float automatically. The second is explicit type conversion, which is also called typecasting. This happens when the programmer manually converts a value using functions like int, float, str, list, tuple, set, or bool. This is very common in real programs. A strong interview answer should also mention that explicit conversion can fail. For example, trying to convert a non-numeric string into an integer will raise an error. So developers must validate data before conversion when necessary. Another important point is that type conversion does not always behave the way beginners expect. For example, converting a float to int removes the decimal part. It does not round automatically. Similarly, converting values to bool follows truthy and falsy rules. In interviews, the best answer is this. Type conversion in Python means transforming data from one type to another. It can happen automatically as implicit conversion or manually through explicit conversion using built-in functions. Understanding when and why to convert types is very important for writing correct Python programs. Next question. What are operators in Python? Operators in Python are special symbols or keywords that perform operations on values and variables. In simple words, operators help us do work such as addition, comparison, assignment, logical checks, and membership testing. For example, if we add two numbers, compare two values, or check whether an item exists in a list, operators are involved. So operators are a basic and very important part of writing Python programs. Python provides different categories of operators. These include arithmetic operators, comparison operators, logical operators, assignment operators, bitwise operators, membership operators, and identity operators. Each category is designed for a different kind of task. A good interview answer should also mention operands. The values on which operators work are called operands. For example, in an expression where two numbers are added, the numbers are operands and the plus symbol is the operator. Another important interview point is that operators do not always work only with numbers. Some operators also work with strings, lists, sets, and other objects depending on the type and behavior supported by that object. For example, plus can also join strings and it can check membership inside collections. In interviews, do not give only a one-line definition. A stronger answer is this. Operators in Python are symbols or keywords used to perform operations on operands. They are essential for calculations, comparisons, assignments, logic building, and working with collections. Python supports multiple categories of operators, and understanding them is necessary for writing correct and efficient code. Next question. What are arithmetic operators in Python? Arithmetic operators are used to perform mathematical operations on numeric values. These are among the most commonly used operators in Python. The main arithmetic operators are addition, subtraction, multiplication, division, floor division, modulus, and exponentiation. Addition is used to add values. Subtraction is used to subtract one value from another. Multiplication is used to multiply values. Division gives the result as a floating point value in Python even when both numbers are integers. Floor division is very important in interviews. It returns the quotient without the decimal part by rounding down toward negative infinity. This is different from normal division. Then we have modulus, which gives the remainder after division. Exponentiation is used to raise a number to a power. A strong answer should also mention that some arithmetic operators work with non-numeric types in special cases. For example, plus can concatenate strings and multiplication can repeat strings or lists by a number. So operator behavior can depend on the data type. Another important interview point is division behavior. In Python, normal division returns a float, unlike some languages where integer division may happen automatically. That is why floor division is used when integer style quotient is needed. So the complete interview answer is this. Arithmetic operators in Python are used for mathematical calculations such as addition, subtraction, multiplication, division, floor division, remainder, and exponentiation. They are commonly used with numbers, but some of them also work with strings and collections depending on the type. Next question, what are comparison operators in Python? Comparison operators are used to compare two values. The result of a comparison is always a Boolean value, which means either true or false. The common comparison operators are equal to, not equal to, greater than, less than, greater than or equal to, and less than or equal to. These operators are used in conditions, filtering, decision-making, loops, and validations. For example, if we want to check whether one number is greater than another or whether two strings are equal, comparison operators are used. They are a basic part of if statements and conditional logic in Python. A very important interview point is the difference between equal comparison and identity comparison. Equal comparison checks whether two values are logically equal. Identity comparison checks whether two references point to the same object in memory. Many beginners confuse these two ideas. Another useful point is that Python allows chained comparisons. This means we can write expressions like checking whether one value is between two other values in a compact and readable way. This is one of the readable features of Python. In interviews, it is also good to mention that comparisons between incompatible types may not always be valid in modern Python. So developers should ensure that comparisons make logical sense. A strong answer is this. Comparison operators in Python are used to compare two operands and return true or false. They are essential for conditional logic, validations, and control flow. A good developer also understands the difference between value comparison and identity comparison. Next question. What are logical operators in Python? Logical operators are used to combine or modify conditional expressions. They are mainly used when we want to work with multiple conditions in a single expression. Python has three logical operators. They are and, or, and not. The AND operator returns true only when both conditions are true. The OR operator returns true if at least one condition is true. The NOT operator reverses the Boolean result of a condition. These operators are widely used in if statements, loops, validations, filtering conditions, and decision-making logic. For example, we may check whether a user is active and has permission or whether a value is missing or invalid. A very important interview point is short circuit evaluation. Python does not always evaluate every part of a logical expression. For and, if the first condition is false, Python already knows the result will be false, so it may not evaluate the second condition. For or, if the first condition is true, Python may skip the second condition because the result is already decided. This behavior is important in real coding because it can improve performance and also prevent errors. For example, developers often use short circuit logic to check whether an object exists before accessing its properties. Another strong interview point is that logical operators in Python do not always return only true or false in every context. They can return one of the actual operands depending on truthiness rules. That makes Python flexible, but developers should understand it clearly. So the complete answer is this. Logical operators in Python are used to combine or negate conditions. They help build complex decision-making expressions, and their short-circuit behavior is an important concept for interviews and real-world coding. Next question. What are assignment operators and what is their use in Python? Assignment operators are used to assign values to variables. The most basic assignment operator is the simple equals operator, which stores a value in a variable. This is one of the most common operations in Python programming. Python also provides compound assignment operators. These combine an operation with assignment in a shorter form. For example, we can update a variable by adding, subtracting, multiplying, dividing, or applying other operations and then storing the result back into the same variable. These operators improve readability and make code shorter. They are commonly used in counters, loops, accumulators, calculations, and state updates. A good interview answer should mention that assignment in Python works through references. When we assign a value to a variable, the variable name becomes bound to an object. This is important because behavior can differ depending on whether the object is mutable or immutable. Another important interview point is multiple assignment. Python allows assigning values to multiple variables in a single statement. This improves readability and is commonly used in unpacking values from tuples, lists, and function returns. You can also mention chained assignment, where the same value is assigned to more than one variable. But here developers should be careful when the assigned value is a mutable object, because multiple names may then refer to the same object. A stronger modern interview answer can also mention the assignment expression operator, sometimes called the walrus operator. It allows assignment inside an expression in certain situations, but it should be used carefully for readability. So the complete answer is this. Assignment operators in Python are used to bind values to variables and update them efficiently. Besides simple assignment, Python supports compound assignment, multiple assignment, and modern assignment expressions. Understanding how assignment works with object references is very important in interviews. Next question. What are membership operators in Python? Membership operators are used to check whether a value exists inside a sequence or collection. Python provides two membership operators. These are in and not in. The in operator checks whether a value is present in an object such as a string, list, tuple, set, or dictionary. If the value exists, the result is true. If the value does not exist, the result is false. The not in operator does the opposite. It checks whether a value is absent from the given collection. If the value is not present, it returns true. A very important interview point is how membership behaves with dictionaries. When we use in with a dictionary, Python checks the keys, not the values. Many beginners make this mistake in interviews and real coding. So if we want to check whether a value exists in a dictionary value list, we must check that explicitly. Another important point is performance. Membership checking in a list may take more time because Python may scan elements one by one. But in sets and dictionaries, membership checks are usually faster because of hash-based lookup. This is a good point to mention in interviews because it shows practical understanding, not just syntax knowledge. Membership operators are widely used in validation, searching, filtering, access checks, and condition building. For example, we may check whether a user role exists in allowed roles, whether a substring exists in text, or whether an item is already present in a collection. So the complete interview answer is this. Membership operators in Python are in and not in. They are used to test whether a value exists inside a sequence or collection. A strong answer should also mention that dictionary membership checks keys by default and that performance differs between lists, sets, and dictionaries. Next question, what are identity operators in Python? Identity operators are used to check whether two variables refer to the same object in memory. Python provides two identity operators. These are is and is not. This is a very important interview topic because many developers confuse identity with equality. Equality checks whether two objects have the same value. Identity checks whether both references point to the exact same object. For example, two different lists may contain the same data. In that case, equality may say they are equal, but identity may still say they are different because they are stored as separate objects in memory. The is operator returns true when both operands refer to the same object. The is not operator returns true when they refer to different objects. A very strong interview point is this. In Python, is should not be used as a replacement for equal comparison in normal value checks. It should mainly be used when identity really matters. The most common correct use is checking against none. For example, it is recommended to use is none and is not none instead of equal comparison for none checks. Another useful interview point is that some small integers and strings may appear to behave strangely with is because of internal caching or interning. That is exactly why developers should not use is for general value comparison. So the complete answer is this. Identity operators in Python are is and is not. They check whether two references point to the same object in memory, not just whether the values are equal. A good developer uses is mainly for identity checks such as none comparison and uses equal comparison for normal value comparison. Next question, what are bitwise operators in Python? Bitwise operators are used to perform operations at the binary level, which means they work on individual bits of integer values. These operators are commonly used in low-level programming, optimization, flags, permissions, masking, and some algorithmic problems. Python provides several bitwise operators. These include bitwise and bitwise or, bitwise exclusive or, bitwise not, left shift and right shift. Bitwise and compares bits of two numbers and returns 1 only where both bits are 1. Bitwise or returns 1 where at least one bit is 1. Bitwise exclusive or returns 1 where the bits are different. Bitwise not inverts the bits. Left shift moves bits to the left and right shift moves bits to the right. In interviews, do not just define them. Also explain where they are used. They are useful when working with permission bits, status flags, compact storage, and fast numeric operations in some cases. For example, a single integer can store multiple on and off flags using different bit positions. A very important interview point is that bitwise operators work with integers, not floating point numbers. Even if Python developers do not use bitwise operators every day, interviewers may ask them to test depth of understanding. So the complete answer is this. Bitwise operators in Python perform operations on the binary representation of integers. They are useful for flags, masks, permissions, and low-level logic. A strong answer should explain both what they do and where they are practically used. Next question. What is operator precedence in Python? Operator precedence means the order in which Python evaluates operators when multiple operators are present in the same expression. In simple words, precedence rules decide which operation happens first. For example, in a mathematical expression, multiplication happens before addition unless parentheses change the order. Python follows similar precedence rules for arithmetic, logical, comparison, bitwise, and other operators. This is very important in interviews because many bugs happen when developers assume the wrong evaluation order. A candidate should understand that Python does not evaluate expressions randomly. It follows a defined order of precedence. A good answer should also mention that parentheses can be used to override default precedence. This is one of the best practices in real coding. Even if you know the precedence rules, adding parentheses can improve readability and avoid confusion. In general, expressions inside parentheses are evaluated first. Then exponentiation has high precedence. After that come multiplication, division, floor division, and modulus. Then addition and subtraction. After that, comparison operators, logical, not, logical, and logical follow their own order. Another important point is that precedence and associativity are different concepts. Precedence decides which operator has higher priority. Associativity decides the direction of evaluation when operators have the same precedence. So the complete interview answer is this. Operator precedence in Python is the rule that determines the order in which operators are evaluated in an expression. Understanding precedence is important for writing correct expressions, and using parentheses is the safest way to make evaluation order clear and readable. Next question. What is associativity in Python operators? Associativity tells us the direction in which Python evaluates operators when more than one operator of the same precedence appears in an expression. This concept becomes important only after precedence has already been considered. In simple words, if two operators have the same priority, associativity tells Python whether to evaluate from left to right or from right to left. Most operators in Python follow left to right associativity. That means evaluation moves from the left side toward the right side when precedence is the same. This is common for arithmetic operators like addition, subtraction, multiplication, and division. However, some operators follow right to left associativity. A common example is exponentiation. This means when multiple exponent operators appear together, Python evaluates them from right to left. A strong interview answer should clearly separate associativity from precedence. Precedence tells us which operator is stronger. Associativity tells us the direction of evaluation when two operators are equally strong. Another important point is that developers should not depend too much on remembering every precedence and associativity detail in complex expressions. In real projects, using parentheses is better because it makes the expression easier to understand and reduces the chance of bugs. Interviewers like this question because it checks whether the candidate truly understands expression evaluation instead of only memorizing operators. If you explain precedence first and then associativity, your answer sounds strong and structured. So the complete answer is this. Associativity in Python defines the direction in which operators of the same precedence are evaluated. Most operators are evaluated from left to right, while some, like exponentiation, are evaluated from right to left. A good developer understands this difference and uses parentheses to keep expressions clear. Let's take a look at the next question. What is a for loop in Python? A for loop in Python is used to iterate over a sequence or any iterable object. In simple words, it allows us to process items one by one without writing repeated code manually. This makes the program shorter, cleaner, and easier to maintain. Python for loops are different from the traditional for loops seen in some other languages. In many languages, a for loop is based on initialization, condition, and increment. But in Python, the for loop is mainly used as a for each loop. It directly iterates over the elements of an iterable such as a list, tuple, string, set, dictionary, or range object. This is a very important interview point. In Python, the for loop is built around iteration, not around manual index control by default. That is one reason Python code often looks cleaner and more readable. A for loop is widely used in real projects for processing collections, reading files line by line, iterating through query results, applying transformations, generating reports, and handling repeated business operations. A strong interview answer should also mention that the loop variable takes one value at a time from the iterable. The loop continues until all items are processed. If needed, functions like range and enumerate are often used with for loops for numeric iteration or index plus value access. So the complete interview answer is this. A for loop in Python is used to iterate over an iterable object and process its elements one by one. It is more like a for each loop than a traditional C-style loop, and it is one of the most common and readable ways to perform repetition in Python. Next question. What is a while loop in Python? A while loop in Python is used to execute a block of code repeatedly, as long as a given condition remains true. This means the loop keeps running until the condition becomes false. In simple words, a while loop is condition-based repetition. If we do not know in advance how many times something should repeat, but we know the condition that controls repetition, a while loop is often a good choice. This is one of the main differences between for and while. A for loop is usually used when iterating over a sequence or iterable. A while loop is usually used when repetition depends on a condition. In real projects, while loops are useful for reading data until some stop condition is reached, retrying an operation until success or failure, processing user input until valid input is received, or running background logic while a system state remains active. A very important interview point is the risk of an infinite loop. If the condition never becomes false, the while loop may continue forever. That is why the loop body usually needs some logic that changes the condition at the correct time. Another strong interview point is that Python also supports an optional else block with loops. In a while loop, the else block runs when the loop finishes normally without hitting a break statement. Many candidates forget this feature, so the complete interview answer is this. A while loop in Python repeats a block of code as long as a condition is true. It is useful for condition-driven repetition, but developers must carefully update the condition to avoid infinite loops. Let's take a look at the next question. What is the difference between for loop and while loop in Python? Both for loop and while loop are used for repetition, but they are designed for different situations. Understanding this difference is very important in interviews because it shows whether the candidate can choose the right control structure. A for loop is mainly used when we want to iterate over an iterable object such as a list, tuple, string, dictionary, set, or range. It is best when the items or sequence to iterate over are already known or naturally available. A while loop is mainly used when repetition depends on a condition. It is suitable when we do not know the exact number of iterations in advance and the loop should continue until some condition changes. So the practical difference is this. For loop is iterable driven, while loop is condition driven. Another important interview point is readability and safety. In many cases, a for loop is safer and easier to read because Python manages the iteration automatically. In a while loop, the developer must usually manage the condition update manually. That makes while loops more flexible but also more error prone if not handled carefully. In real-world coding, if we are processing each item in a collection, a for loop is usually the better choice. If we are waiting for a condition, retrying logic, or reading input until a stop signal, a while loop is usually better. So the complete interview answer is this. The difference between for loop and while loop in Python is that a for loop is used for iterating over iterable objects, while a while loop is used for repeating code as long as a condition remains true. For loops are generally more readable for sequence iteration, while loops are more flexible for condition-based repetition. Next question, what is break in Python loops? The break statement is used to exit a loop immediately before the loop finishes normally. As soon as Python encounters break inside a loop, the loop stops and control moves to the next statement after the loop. This is very useful when we want to stop looping early after a specific condition is met. For example, if we find a target value in a list, if a user enters a stop command, or if an error condition occurs during repeated processing, break can stop the loop right away. A strong interview point is that break works in both for loops and while loops. It is not limited to one specific loop type. Another very important interview point is loop else behavior. Python allows an else block with the loops. That else block runs only if the loop finishes normally. If the loop ends because of break, the else block does not run. This is a classic Python interview concept. Break is useful, but it should be used carefully. Too many break statements inside deeply nested logic can make code harder to understand. Good developers use it when it improves clarity, not when it creates confusing control flow. In nested loops, break only exits the innermost loop in which it appears. This is also a good point to mention in interviews because many people assume it exits all loops, which is not correct. Let's take a look at the next question. What is the difference between break, continue, and pass in Python? This is a very common Python interview question because these three statements look similar to beginners, but they serve very different purposes. Break is used to stop the loop completely. As soon as Python sees break, it exits the current loop and moves to the statement after the loop. Continue is different. It does not stop the loop. Instead, it skips the remaining code in the current iteration and moves directly to the next iteration of the loop. So continue is useful when we want to ignore only certain cases, not end the full loop. Pass is different from both. Pass does nothing at all. It is a placeholder statement. Python requires a statement in certain blocks such as functions, classes, loops, or conditions. If we want to leave the block empty temporarily, we use pass so that the code remains syntactically valid. A good interview answer should clearly separate their roles. Break ends the loop. Continue skips the current iteration. Pass simply acts as a no operation placeholder. Another strong point is usage context. Break and continue are meaningful inside loops. Pass can be used in loops, functions, classes, or conditional blocks when no action is needed yet. So the complete interview answer is this. Break, continue, and pass are three different control statements in Python. Break terminates the loop completely, continue skips the rest of the current iteration and moves to the next one, and pass does nothing but acts as a placeholder where Python syntax requires a statement. Let's take a look at the next question. What is a string in Python? A string in Python is a sequence of characters used to store text data. These characters can be letters, numbers, symbols, spaces, or a mix of all of them. Strings are one of the most commonly used data types in Python because almost every program works with text in some form. For example, names, email addresses, messages, file paths, user input, JSON data, and log content are often handled as strings. So strings are not just basic theory. They are used everywhere in real-world Python development. In Python, a string is created by enclosing text inside quotes. Python supports single quotes, double quotes, and triple quotes. Single and double quotes are usually used for normal strings. Triple quotes are often used for multi-line text or docstrings. A very important interview point is this. A string in Python is not just text. It is an object of the built-in str type. That means strings come with many useful methods for searching, formatting, splitting, replacing, and transforming text. Another strong point is that strings are ordered sequences. This means we can access individual characters using indexing, and we can extract parts of a string using slicing. So the complete interview answer is this. A string in Python is a sequence of characters used to represent text. It is an object of type str created using quotes, and it supports many useful operations like indexing, slicing, formatting, and text manipulation. Strings are one of the most important and frequently used data types in Python programming. Next question, how do we create strings in Python? Strings in Python can be created by placing text inside quotes. Python allows three main ways to create them. We can use single quotes, double quotes, or triple quotes. Single quotes and double quotes are functionally very similar for normal text. Developers choose one based on readability, style, or the need to include quotation marks inside the string without escaping them. Triple quotes are used when we want multi-line strings. They are also commonly used for docstrings in functions, classes, and modules. This is a good interview point because docstrings are not just comments. They are actual string literals that Python can access at runtime. Another way to create strings is by converting other data types using the str function. For example, numbers, booleans, or other objects can be converted into string form when needed. This is very common in logging, printing, debugging, and formatting output. A strong interview answer should also mention raw strings and formatted strings. Raw strings are useful when backslashes should be treated literally, such as file paths or regular expressions. Formatted strings, especially of strings, are used to insert variable values directly into text in a clean and readable way. So the complete interview answer is this. Strings in Python are mainly created using single quotes, double quotes, or triple quotes. They can also be created by converting other values using str, and Python provides raw strings and formatted strings for practical use cases. A strong answer should mention both basic creation and common real-world variations. Let's take a look at the next question. What does it mean that strings are immutable in Python? When we say strings are immutable in Python, it means that once a string object is created, its contents cannot be changed in place. We cannot directly modify a single character or part of an existing string object. This is one of the most important string interview questions because immutability affects behavior, memory usage, performance patterns, and coding style. For example, if we perform an operation like replacing text, changing case, or concatenating strings, Python does not modify the original string object directly. Instead, it creates a new string object and returns it. A very strong interview point is this. Since strings are immutable, they are safer to share and easier to reason about in many situations. This also makes them hashable, which is why strings can be used as dictionary keys and set elements. Another important point is performance. Beginners often build large strings by repeated concatenation inside loops. Because strings are immutable, that can create many intermediate objects and may be inefficient. In such cases, using a list of pieces and joining them later is often better. In interviews, it is also useful to contrast this with mutable types like lists. Lists can be changed in place, but strings cannot. So the complete interview answer is this. String immutability in Python means the content of a string cannot be changed after the string is created. Any apparent modification actually creates a new string object. This design improves safety and makes strings hashable, but it also means developers should be careful with repeated string building in performance-sensitive code. Next question. What are indexing and slicing in Python strings? Since strings in Python are ordered sequences of characters, we can access their contents in two common ways. These are indexing and slicing. Indexing means accessing a single character at a specific position. Python uses zero-based indexing, which means the first character is at position 0, the second is at position 1, and so on. This is a basic but very important interview point. Python also supports negative indexing. This allows us to access characters starting from the end of the string. For example, -1 refers to the last character, -2 to the second last, and so on. Slicing is used to extract a portion of the string instead of just one character. A slice can define a start position, an end position, and an optional step. The start index is included, but the end index is excluded. This is one of the most common interview details. A strong interview answer should also mention that slicing returns a new string because strings are immutable. It does not modify the original string. Another useful point is that slicing is very flexible. It can be used to get substrings, skip characters, reverse text, or extract patterns. This is heavily used in parsing, validation, and text transformation tasks. So the complete interview answer is this. Indexing in Python strings is used to access individual characters by position, while slicing is used to extract a range of characters. Python supports both positive and negative indexing, and slicing returns a new string without changing the original one. Let's take a look at the next question. What are some commonly used string methods in Python? Python provides many built-in string methods that make text processing very easy. This is one reason Python is so powerful for everyday programming, scripting, data cleaning, and automation tasks. Some of the most commonly used string methods are used for changing case. For example, we often convert text to lowercase, uppercase, title case, or capitalize only the first character. Another group of methods is used for cleanup and formatting. These include removing extra spaces from the beginning or end, replacing parts of a string, and joining multiple pieces into one string. We also have methods for splitting and searching. Splitting is used to break a string into parts based on a separator. Searching methods help us find whether text starts with something, ends with something, or contains a specific substring. A strong interview answer should mention that most string methods do not modify the original string because strings are immutable. Instead, they return a new string or a new result. Another practical point is that string methods are heavily used in form validation, log parsing, file processing, CSV handling, API data cleanup, and user input normalization. So this is not only theoretical knowledge, it is part of daily Python development. In interviews, it is better to group methods by purpose instead of randomly listing names. That makes your answer sound structured and mature. So the complete answer is this. Commonly used string methods in Python include methods for case conversion, trimming spaces, replacing text, splitting strings, joining strings, and checking prefixes or suffixes. Since strings are immutable, these methods usually return new results instead of modifying the original string. These methods are widely used in real-world text processing tasks. Let's take a look at the next question. What is a list in Python? A list in Python is an ordered, mutable collection used to store multiple values in a single variable. This means a list keeps the insertion order and it can be changed after creation. That is one of the main reasons lists are used so heavily in Python programs. A list can store elements of the same type or different types. For example, a list may contain integers, strings, floating point values, or even other lists. This flexibility makes lists very useful in real-world programming. Lists are commonly used for storing collections of data such as student names, product prices, API results, file names, or database records loaded into memory. Whenever we need a sequence of items that may grow, shrink, or change, a list is often the first choice in Python. A very important interview point is this. A list is ordered and mutable, and it also allows duplicate values. This helps distinguish it from tuples, sets, and dictionaries. A tuple is ordered but immutable. A set is unordered and stores unique values. A dictionary stores key value pairs. A strong answer should also mention that a list is an object of the built-in list type and supports many useful methods for adding, removing, sorting, and processing items. So the complete interview answer is this. A list in Python is an ordered and mutable collection that can store multiple values, including duplicate values and mixed data types. It is one of the most commonly used data structures in Python because it is flexible, easy to use, and very useful for real-world data processing. Next question. How do we create lists in Python? Lists in Python are usually created by placing comma-separated values inside square brackets. This is the most common and most readable way to create a list. A list can be empty, or it can contain one or more elements. It can also contain mixed data types if needed. For example, Python does not force all list elements to be of the same type. Another way to create a list is by using the list constructor. This is useful when converting another iterable, such as a string, tuple, set, or range object into a list. This is a good interview point because list creation is not limited only to square brackets. Lists can also be created using list comprehensions. This is a very powerful and Pythonic way to create lists from existing iterables while optionally applying conditions or transformations. Interviewers often expect candidates to know that list comprehensions are an important part of Python list usage. A strong answer should also mention nested list. A list can contain other lists as elements. This is useful for matrix-like structures, grouped records, or hierarchical data. In real-world coding, list creation happens everywhere, such as when reading CSV rows, storing API response items, collecting file names, or generating values in loops. So the complete interview answer is this. Lists in Python are mainly created using square brackets with comma-separated values. They can also be created using the list constructor or list comprehensions. Python lists are flexible because they can be empty, contain mixed types, or even contain other lists. Let's take a look at the next question. What does it mean that lists are mutable in Python? When we say lists are mutable in Python, it means their contents can be changed after the list is created. We can add elements, remove elements, update elements, reorder elements, and modify parts of the list without creating a completely new list object every time. This is one of the most important differences between lists and strings or tuples. Strings and tuples are immutable, which means they cannot be changed in place. But lists support in-place modification. This matters a lot in interviews because mutability affects assignment behavior, function arguments, copying, and memory sharing. So the complete interview answer is this. List mutability in Python means a list can be changed after it is created. Its elements can be added, removed, updated, or reordered in place. This makes list very useful for dynamic programming tasks, but developers must understand reference sharing and copying behavior carefully. Next question. How do indexing and slicing work in Python lists? Since lists are ordered collections, Python allows us to access their elements using indexing and slicing. These work very similarly to strings because both are sequence types. Indexing is used to access a single element at a specific position. Python uses zero-based indexing, which means the first element is at index 0, the second at index 1, and so on. This is a basic but very important interview concept. Python also supports negative indexing with lists. This means we can access elements starting from the end. -1 gives the last element, -2 gives the second last element, and so on. Slicing is used to extract a portion of a list instead of just one element. A slice can define a start index, an end index, and an optional step. The start is included and the end is excluded. This is one of the most common points interviewers expect candidates to explain correctly. A very strong interview point is this. List slicing returns a new list. It does not modify the original list unless we use slice assignment explicitly. That makes slicing useful for copying, extracting sublists, skipping elements, or reversing a list. In real projects, indexing and slicing are used in pagination logic, batch processing, parsing records, extracting ranges, and working with recent or last elements in a collection. So the complete interview answer is this. Indexing in Python lists is used to access individual elements by position, while slicing is used to extract a portion of the list. Python supports both positive and negative indexing, and slicing returns a new list based on the specified range and step. Let's take a look at the next question. What are some commonly used list methods in Python? Python lists provide many built-in methods that make them very practical for daily programming. These methods are used to add, remove, search, reorder, and process list elements. Some commonly used methods are used for adding elements. For example, we can add a single item at the end, insert an item at a specific position, or extend the list with multiple elements from another iterable. Another important group of methods is used for removing elements. We may remove by value, remove by position, or clear the entire list depending on the need. Lists also support methods for searching and counting. For example, we can find the position of an element or count how many times an element appears. Reordering methods are also very important. We can sort a list, reverse a list, or create a copy of the list. A strong interview point is that some list methods modify the list in place instead of returning a new list. For example, sorting and reversing usually change the original list directly. This is very important because beginners often expect a new list to be returned in every case. A good interview answer should also mention the difference between methods and built-in functions. For example, length, minimum, maximum, and sum are common built-in functions used with lists, even though they are not list methods themselves. So the complete interview answer is this. Commonly used list methods in Python include methods for adding elements, inserting elements, extending lists, removing items, counting values, finding positions, sorting, reversing, and copying. A strong answer should also mention that many list methods modify the original list in place, which is an important practical difference in Python programming. Let's take a look at the next question. What is a tuple in Python? A tuple in Python is an ordered collection used to store multiple values in a single variable. At first look, it may seem similar to a list, but the most important difference is that a tuple is immutable. That means once a tuple is created, its contents cannot be changed in place. A tuple keeps the insertion order and also allows duplicate values. It can store elements of the same type or different types. For example, a tuple may contain numbers, strings, booleans, or even nested objects. In Python, tuples are commonly used when the data should not change after creation. For example, coordinates, fixed configuration values, database records returned as structured groups, and multi-value function returns are common use cases. A very important interview point is this. Tuple immutability makes tuples safer for fixed data and in many cases slightly lighter than list. Also, if a tuple contains only hashable elements, it can itself be hashable and can be used as a dictionary key or as a set element. This is something lists cannot do because lists are mutable. A strong answer should also mention that even though the tuple itself is immutable, if it contains a mutable object like a list, that inner object can still be changed. This is a classic Python interview point. So the complete interview answer is this. A tuple in Python is an ordered and immutable collection that allows duplicate values and can store mixed data types. It is useful when data should remain fixed after creation, and it is commonly used for grouped values, function returns, and hashable structured data. Next question. What is the difference between a list and a tuple in Python? This is one of the most common Python interview questions because lists and tuples look similar, but they are used for different purposes. The first and most important difference is mutability. A list is mutable, which means it can be changed after creation. A tuple is immutable, which means its structure cannot be changed once it is created. The second difference is syntax. Lists are usually created using square brackets, while tuples are usually created using parentheses. Although technically the comma is the key part in a tuple, parentheses are the common style. Another important difference is use case. Lists are used when data may change over time, such as dynamic collections, user input, records, or processed results. Tuples are used when data should stay fixed, such as coordinates, constant settings, or grouped return values from functions. A strong interview point is performance and memory behavior. Tuples are generally a little lighter than lists because they are immutable. This does not mean tuples are always a huge optimization, but it is still a valid conceptual difference. Another very important point is hashability. Lists cannot be used as dictionary keys because they are mutable. Tuples can be used as dictionary keys if all their elements are hashable. So the complete interview answer is this. The main difference between a list and a tuple in Python is that a list is mutable and a tuple is immutable. Lists are better for dynamic data, while tuples are better for fixed grouped data. Tuples are also more suitable when hashability is needed, such as dictionary keys or set elements. Let's take a look at the next question. What is a set in Python? A set in Python is an unordered collection of unique elements. This means a set does not maintain insertion-based indexing like a list or tuple, and it automatically removes duplicate values. That is the core idea of a set. Sets are very useful when uniqueness matters. For example, if we want to remove duplicate values from a collection, track unique users, compare tags, or perform mathematical set operations, Python sets are very effective. A very important interview point is this. Sets are mutable, so we can add or remove elements after creation. But the elements inside a set must be hashable. That means mutable objects like lists cannot be stored as set elements. Another strong point is performance. Sets are usually very fast for membership testing. Checking whether an element exists in a set is generally faster than checking in a list, especially for large collections. This is a great practical point to mention in interviews. A good answer should also mention that sets do not support indexing or slicing because they are unordered collections. So if we need position-based access, a set is not the correct structure. So the complete interview answer is this. A set in Python is an unordered and mutable collection that stores only unique elements. It is widely used for duplicate removal, membership testing, and set-based operations like union, intersection, and difference. A strong answer should also mention that set elements must be hashable. Let's take a look at the next question. What are common set operations in Python? Python sets support many important operations, and this is one of the reasons they are very powerful in interviews and real-world programming. The most common set operations are union, intersection, difference, and semantic difference. Union combines elements from two sets and keeps all unique values from both. Intersection gives only the elements that are common in both sets. Difference gives the elements that are present in one set but not in the other. Semantic difference gives the elements that are in either set but not in both. These operations are very useful in real scenarios. For example, we may compare user roles, detect common tags, identify missing permissions, find newly added items, or remove duplicates across multiple data sets. A strong interview answer should also mention subset and superset concepts. A subset means all elements of one set are contained in another set. A superset means one set contains all elements of another set. These checks are useful in permission systems, validation rules, and coverage checks. Another practical point is that Python supports both operator-based and method-based ways to perform set operations. That makes the syntax flexible and readable. So the complete interview answer is this. Common set operations in Python include union, intersection, difference, and semantic difference. Sets also support subset and superset checks. These operations are very useful for comparing collections, removing duplicates, and solving problems based on unique values and relationships between groups of data. Let's take a look at the next question. What is a dictionary in Python? A dictionary in Python is a built-in data structure used to store data in key value pairs. This means every value in the dictionary is associated with a unique key. Instead of accessing data by position like a list or tuple, we access dictionary data by key. This is one of the most important Python data structures because many real-world problems involve mapping one thing to another. For example, a dictionary can store employee details, student marks, product information, configuration values, API response fields, or lookup tables. A very important interview point is this. A dictionary is mutable. That means we can add new key value pairs, update existing values, and remove entries after the dictionary is created. Another strong point is that dictionary keys must be unique. If the same key is assigned again, the old value is replaced by the new value. This is a common interview expectation. A good answer should also mention that dictionaries are highly optimized for fast lookup by key. That is one reason they are used so often in Python programming. In modern Python, dictionaries preserve insertion order. This is also a valuable interview point especially when discussing current Python behavior. So the complete interview answer is this. A dictionary in Python is a mutable data structure that stores data as key-value pairs. It is used when we want to map keys to values for fast and readable data access. Dictionaries are widely used in real-world Python programs for structured and lookup-based data handling. Next question. What are the rules for dictionary keys in Python? Dictionary keys in Python follow some important rules, and this is a very common interview question. The first rule is that keys must be unique. A dictionary cannot store two separate entries with the same key. If we assign a value to an existing key again, the previous value is overwritten. The second major rule is that dictionary keys must be hashable. This means the key must have a stable hash value and must be comparable in a consistent way. In practical terms, immutable types like integers, strings, booleans, and tuples with hashable contents can be used as keys. A very important interview point is that mutable types like lists, sets, and dictionaries cannot be used as keys. That is because their contents can change, which would break the hash-based lookup system used internally by Python dictionaries. Another strong point is that keys do not all have to be of the same type. Python allows mixed key types, although in clean production code, developers usually keep key types consistent for readability and maintainability. It is also good to mention that while values in a dictionary can be duplicated, keys cannot. This helps distinguish the role of keys and values clearly. So the complete interview answer is this. The rules for dictionary keys in Python are that keys must be unique and hashable. Immutable types like strings, numbers, and suitable tuples can be used as keys, while mutable types like lists and dictionaries cannot. This is because Python dictionaries use hashing for fast key-based access. Let's take a look at the next question. What is a function in Python? A function in Python is a reusable block of code designed to perform a specific task. Instead of writing the same logic again and again, we write it once inside a function and call it whenever needed. This makes code shorter, cleaner, and easier to maintain. Functions are one of the most important concepts in Python because they help break a large problem into smaller and manageable parts. This improves readability and makes the code more modular. A well-designed program usually contains many small functions where each function handles one clear responsibility. In Python, a function is defined using the def keyword. After defining it, we can call the function by using its name followed by parentheses. A strong interview point is this. A function may take input values, process them, and optionally return a result. Some functions are created by the programmer and some are built into Python, like print, len, and type. Another important point is why functions matter in real-world projects. They help in reusability, testing, debugging, and separation of concerns. If business logic is placed inside functions properly, it becomes much easier to update one part of the application without affecting the whole program. So the complete interview answer is this. A function in Python is a reusable block of code that performs a specific task. It helps organize logic into smaller units, improves code reuse, readability, maintainability, and makes programs easier to test and manage. Next question. What is the difference between parameters and arguments in Python? This is a very common interview question, and many people use these two words as if they mean the same thing. But technically, parameters and arguments are different. Parameters are the variable names written in the function definition. They act like placeholders that show what kind of input the function expects. Arguments are the actual values passed to the function when the function is called. In simple words, parameters belong to the function definition and arguments belong to the function call. For example, if a function is defined to accept two values, those names inside the function header are parameters. When we actually call the function and pass real values, those real values are arguments. A strong interview point is that Python supports different kinds of arguments. These include positional arguments, keyword arguments, default arguments, and variable length arguments. So understanding parameters and arguments is important before moving into advanced function topics. Another useful point is that good parameter naming improves readability. A function definition should clearly communicate what input it expects. This makes the code more understandable for other developers. So the complete interview answer is this. Parameters are the names defined in the function signature, while arguments are the actual values passed during the function call. Parameters act as placeholders and arguments provide the real data that the function works with. Let's take a look at the next question. What are return values in Python functions? A return value is the result that a function sends back to the place from where it was called. In Python, this is done using the return statement. When the function reaches a return statement, it immediately exits and gives back the specified value. Return values are very important because they allow functions to produce output that can be stored, reused, passed to another function, or used in expressions. Without return values, many functions would only perform actions but would not provide useful results back to the program. A very important interview point is this. If a Python function does not explicitly return a value, Python automatically returns none. Many beginners forget this, but interviewers often expect this point. Another strong point is that a function can return different types of values. It may return a number, string, list, dictionary, object, boolean, or even multiple values. When multiple values are returned, Python actually returns them as a tuple. A good interview answer should also explain the difference between print and return. Print only displays a value on the screen. Return sends the value back to the caller so that the program can use it further. This is one of the most common beginner interview questions. So the complete interview answer is this. Return values in Python functions are the results sent back to the caller using the return statement. They allow functions to produce reusable output. If no explicit return is written, Python returns none by default. Next question. What are default arguments in Python? Default arguments are function parameters that already have a default value assigned in the function definition. This means if the caller does not provide a value for that parameter, Python automatically uses the default value. This feature makes functions more flexible. It allows a function to be called with fewer arguments when some values are optional or commonly repeated. This helps reduce unnecessary code and makes the function easier to use. A strong interview point is this. Default arguments must come after non-default parameters in the function definition. In other words, required parameters should be written first and optional parameters with default values should come later. This is a syntax rule in Python. Another very important interview point is the mutable default argument issue. If we use a mutable object like a list or dictionary as a default argument, that same object is reused across function calls. This can create unexpected bugs. That is why developers usually use none as the default and create a new object inside the function when needed. In real-world coding, default arguments are used for optional configuration values, message prefixes, retry counts, formatting options, and many other practical cases. So the complete interview answer is this. Default arguments in Python are parameters that have predefined values in the function definition. If the caller does not pass a value, Python uses the default one. They make functions more flexible, but mutable default values should be avoided because they can cause unexpected behavior across calls. Next question: what is a lambda function in Python? A lambda function in Python is a small anonymous function written in a compact single expression form. Anonymous means it can be created without giving it a normal function name in the same way as a regular function. Lambda functions are mainly used when we need a short function for a small purpose and do not want to define a full function using def. They are often used in places where a function is needed temporarily, such as sorting, mapping, filtering, or passing behavior as an argument. A very important interview point is this: a lambda function can contain only a single expression, not multiple statements. That means it is good for simple logic but not suitable for complex business rules. Another strong interview point is that lambda functions are still real function objects. They can be assigned to variables, passed to other functions, or returned from functions just like regular functions. In real projects, lambda functions are commonly used with functions like sort, map, filter, reduce, or event callbacks. But in clean code, developers should avoid using lambda when it reduces readability. If the logic becomes even slightly complex, a normal named function is usually better. Interviewers often ask whether lambda is faster or better than a normal function. The better answer is that lambda is mainly about convenience and compactness, not about replacing proper named functions everywhere. So the complete interview answer is this: a lambda function in Python is a small anonymous function written as a single expression. It is useful for short and temporary function logic, especially when passing functions as arguments, but regular named functions are better when the logic becomes more complex or needs better readability. Let's take a look at the next question. What is variable scope in Python? Variable scope in Python means the region of the program where a variable is visible and accessible. In simple words, scope tells us where a variable can be used and from where it can be accessed. This is a very important interview topic because many Python bugs happen due to misunderstanding variable scope. A variable may exist in one part of the program but may not be available in another part. Python mainly follows 4 scope levels, often explained with the LEGB rule. These are local, enclosing, global, and built-in. Local scope means variables created inside a function. Enclosing scope refers to variables in outer functions when functions are nested. Global scope refers to variables defined at the module level. Built-in scope includes names already provided by Python, such as print or len. A strong interview point is this: when Python looks for a variable name, it searches these scopes in order. First local, then enclosing, then global, and finally built-in. Another very important point is the use of global and non-local. These keywords are used when we want to modify variables from outer scopes. But in real-world coding, excessive use of global variables is usually avoided because it makes code harder to maintain and test. So the complete interview answer is this: variable scope in Python defines where a variable is accessible in a program. Python resolves variable names using the LEGB rule, which stands for local, enclosing, global, and built-in scope. Understanding scope is very important for writing correct functions, avoiding name conflicts, and managing state cleanly in Python applications. Next question: what is a recursion in Python? Recursion is a technique where a function calls itself in order to solve a problem. Instead of solving the whole problem at once, the function solves a smaller part of the same problem again and again until it reaches a stopping condition. That stopping condition is called the base case. This is one of the most important interview points in recursion. Without a base case, the function would keep calling itself forever and eventually fail due to maximum recursion depth. Recursion is useful in problems that naturally break into smaller similar subproblems. Common examples include factorial calculation, Fibonacci series, tree traversal, directory processing, and divide and conquer algorithms. A strong interview answer should explain that recursion has two parts. One is the base case, which stops the recursion. The other is the recursive case, where the function calls itself with a smaller or simpler input. Another important point is that recursion is elegant and expressive for some problems, but it is not always the most efficient approach in Python. Recursive calls add function call overhead, and deeper recursion may hit Python's recursion depth limit. So in some cases, an iterative solution may be more practical. Interviewers often like this question because it tests both logical thinking and understanding of function flow. So the complete interview answer is this. Recursion in Python is a technique where a function calls itself to solve a problem by reducing it into smaller, similar sub-problems. A correct recursive solution must have a base case to stop the calls and a recursive case to move toward that stop condition. It is powerful for some problems, but developers must also consider readability, performance, and recursion depth limits. Let's take a look at the next question. What is a class in Python? A class in Python is a blueprint used to create objects. It defines the structure and behavior that objects created from it will have. In simple words, a class tells Python what data an object should store and what actions that object can perform. This is one of the most important concepts in object-oriented programming. Instead of managing related data and functions separately, a class allows us to group them together in a meaningful way. That makes code more organized, reusable, and easier to maintain. For example, if we are building a student management system, we may define a student class. That class can describe what data a student object has, such as name, roll number, and marks, and what actions it can perform, such as displaying details or calculating a result. A strong interview point is this. A class itself is not the actual real-world entity. It is the template. The actual entities created from that template are called objects. Another important point is that Python classes support object-oriented features like encapsulation, inheritance, polymorphism, and abstraction. That is why classes are widely used in real-world application design. So the complete interview answer is this. A class in Python is a blueprint for creating objects. It defines the attributes and methods that objects of that type will have. Classes help organize code into reusable and structured units, which is the foundation of object-oriented programming in Python. Next question. What is an object in Python? An object in Python is an instance of a class. When we create something from a class, the result is an object. If a class is the blueprint, then the object is the actual item created from that blueprint. This is a very important interview concept because many people define class and object but do not clearly explain their relationship. A class defines the structure while an object holds the actual data and uses the behavior defined by the class. For example, if we have an employee class, then one object may represent one employee with specific data such as a particular name, salary, and department. Another object from the same class may represent another employee with different values. A strong interview point is this. Each object gets its own state. That means different objects created from the same class can store different data in their instance variables. But they can still share the same method definitions from the class. Another useful point is that in Python, everything is treated as an object. Numbers, strings, lists, functions, and even classes themselves are objects in Python. This is a deeper concept that interviewers often like to hear. So the complete interview answer is this. An object in Python is an instance of a class. It contains actual data and can use the methods defined by its class. Objects represent real entities in a program, and multiple objects can be created from the same class with different states. Let's take a look at the next question. What is a constructor in Python? A constructor in Python is a special method that is automatically called when an object is created. Its main purpose is to initialize the object. That means it sets up the initial state of the object by assigning values to its instance variables or performing any required setup work. In Python, the constructor is commonly written using the special method named _init_. This is one of the most frequently asked Python interview questions. Many interviewers want to check whether the candidate understands that this method is automatically called during object creation. A strong interview point is this: $_init_ is not the object creation step itself. It is the initialization step after the object has been created. The actual low-level object creation is handled by another special mechanism in Python. This is a more advanced point, but it makes your answer stronger. Constructors are used to set default values, assign user-provided values, prepare resources, and ensure that the object starts in a valid state. Without a constructor, we may have to assign everything manually after creating the object, which is less clean and less safe. So the complete interview answer is this. A constructor in Python is a special method that runs automatically when an object is created and is mainly used to initialize the object. In practice, this is usually done through the $_init_ method, which sets the initial state of the object. Let's take a look at the next question. What are instance variables in Python? Instance variables are variables that belong to an object. They store the data or state of that specific object. This means different objects of the same class can have different values in their instance variables. For example, if we create a car class, one object may have a color value of red, while another object may have a color value of blue. The variable that stores the color for each object is an instance variable. In Python, instance variables are usually created inside the constructor using self. The self reference points to the current object, and it allows the object to store its own data. This is a very important interview point. If we do not use self, the variable will not become part of the object state in the normal way. A strong interview answer should also distinguish instance variables from class variables. Instance variables are unique to each object. Class variables are shared across all objects of the class unless overridden. Another practical point is that instance variables are heavily used in real-world code to represent user data, configuration per object, runtime state, counters, balances, statuses, and many other entity-specific values. So the complete interview answer is this. Instance variables in Python are variables that belong to a specific object and store that object's individual state. They are usually created using self inside the constructor or other instance methods. Each object can have different values in its instance variables, which is what makes objects hold their own data. Next question. What are methods in Python classes? Methods in Python classes are functions defined inside a class. They describe the behavior of objects created from that class. In simple words, if instance variables represent the data of an object, methods represent the actions the object can perform. For example, if we have a bank account class, methods may be used to deposit money, withdraw money, and display balance. This makes the class more meaningful because it combines both data and behavior. A very important interview point is this. Instance methods in Python usually take self as the first parameter. This allows the method to access the current object's data and other methods. When the method is called through an object, Python automatically passes that object as self. A strong answer should also mention that Python supports different types of methods. The most common are instance methods. But Python also supports class methods and static methods for special use cases. Even if the question is basic, mentioning this briefly makes the answer stronger. Another important point is that methods help enforce object-oriented design. Instead of changing object data from everywhere in the program, we can define clear actions inside the class itself. This improves encapsulation and maintainability. So the complete interview answer is this. Methods in Python classes are functions defined inside a class that represent the behavior of objects. They operate on object data and are usually written as instance methods using self. Methods are a key part of object-oriented programming because they combine behavior with the data stored inside objects. Let's take a look at the next question. What is exception handling in Python? Exception handling in Python is the process of dealing with runtime errors in a controlled way, so that the program does not crash unexpectedly. In simple words, when something goes wrong during program execution, exception handling allows us to catch that problem and respond properly. This is very important in real-world applications because errors can happen for many reasons. A file may not exist. A user may enter invalid data. A network request may fail. A database connection may not be available. If we do not handle such situations, the application may stop suddenly and give a poor user experience. Python handles exceptions using blocks like try, except, else, and finally. The main idea is that risky code is placed inside the try block. If an error happens, Python transfers control to a matching except block. A strong interview point is this. Exception handling is not only about preventing crashes. It is also about writing reliable, maintainable, and user-friendly software. Good exception handling allows logging, cleanup, fallback logic, and proper error messages. Another important point is that exception handling should not hide real problems silently. Catching errors without proper action can make debugging harder. So the complete interview answer is this. Exception handling in Python is a mechanism for detecting and responding to runtime errors without stopping the program unexpectedly. It helps make applications more robust, readable, and user-friendly by allowing developers to catch errors and handle them properly. Next question, what is the difference between syntax errors and exceptions in Python? This is a very common interview question because it checks whether the candidate understands different kinds of errors clearly. A syntax error happens when the Python code itself is written incorrectly according to language rules. In that case, Python cannot even properly parse the code before running it. For example, missing required punctuation, invalid indentation, or writing statements in an incorrect structure can cause syntax errors. An exception is different. An exception happens during program execution after the code has already passed syntax checking. This means the code is syntactically valid, but something goes wrong at runtime. For example, dividing by 0, accessing a missing key, opening a file that does not exist, or converting invalid text to an integer can raise exceptions. A strong interview point is this. Syntax errors must be fixed in the code before the program can run. Exceptions can often be anticipated and handled in the program using exception handling. Another useful point is that syntax errors are usually programming mistakes. Exceptions may come from programming mistakes, invalid user input, missing resources, or unexpected external conditions. So the complete interview answer is this. The difference between syntax errors and exceptions in Python is that syntax errors happen when the code breaks Python language rules and cannot run, while exceptions happen during runtime after the code has already started executing. Syntax errors must be corrected in the source code, while exceptions can often be caught and handled programmatically. Let's take a look at the next question. What is the purpose of try and except blocks in Python? The purpose of try and except blocks in Python is to handle code that may raise an exception at runtime. This allows the program to respond gracefully instead of crashing immediately. The try block contains the code that may cause an error. Python attempts to execute that code normally. If no exception occurs, the program continues. If an exception occurs, Python stops executing the remaining code inside the try block and looks for a matching except block. The except block contains the logic for handling that specific error. This might include showing a user-friendly message, writing an error to logs using a fallback value, or taking corrective action. A strong interview point is this. Try and except should be used around code that is genuinely risky, not around the entire program without thought. It is better to keep the try block as small and focused as possible. That makes debugging easier and prevents catching unrelated problems by mistake. Another important point is that catching very broad exceptions without proper reason is usually not a good practice. It can hide bugs and make systems harder to maintain. So the complete interview answer is this. Try and except blocks in Python are used to handle runtime errors safely. The try block contains risky code, and the except block defines how to respond if an exception occurs. They help make programs more reliable, but they should be used carefully and specifically. Let's take a look at the next question. What is the role of else and finally in exception handling? In Python exception handling, else and finally provide additional control after the try block. They are not always required, but they are very useful when we want cleaner and more structured error handling logic. The else block runs only if the try block completes successfully without raising an exception. This is a very important interview point. Else is useful for code that should run only when no error happens. It helps separate the main success logic from the risky code and makes the program easier to read. The finally block is different. It runs no matter what happens. Whether an exception occurs or not, whether it is handled or not, the finally block is used for cleanup work that must happen. For example, closing files, releasing resources, disconnecting database connections, or performing final cleanup actions are common uses. A strong interview answer should mention that finally is especially important for resource management. Even if an error happens, cleanup code should still run. Another useful point is that else improves clarity because it keeps non-error logic separate from the try block. That makes the code easier to maintain. So the complete interview answer is this. In Python exception handling, the else block runs only when the try block succeeds without errors, while the finally block runs in all cases and is mainly used for cleanup work. Together, they help make error handling code more structured, readable, and reliable. Let's take a look at the next question. How do we raise exceptions manually in Python? In Python, we can raise exceptions manually when we want to signal that something is wrong according to our own program logic. This is done using the raise statement. Manual exception raising is very useful when the program detects an invalid condition that Python itself does not automatically treat as an error. For example, we may want to reject a negative age, an empty required value, an invalid business rule, or an unsupported operation. In such cases, raising an exception makes the problem explicit and stops normal execution until it is handled. A strong interview point is this: raising exceptions is part of writing defensive and reliable code. Instead of allowing incorrect data to move deeper into the system, we fail early and clearly. Another important point is that Python allows us to raise built-in exceptions or custom exceptions. Built-in exceptions are useful when they match the situation clearly. Custom exceptions are useful when the application needs domain-specific error meaning. You can also mention re-raising. Sometimes we catch an exception, log it or add context, and then raise it again so that higher layers can still handle it properly. So the complete interview answer is this: we raise exceptions manually in Python using the raise statement. This is useful when our own business logic detects invalid conditions and we want to stop execution with a clear error. Manual raising helps enforce validation, maintain clean program flow, and make problems explicit instead of allowing bad data to continue silently. Let's take a look at the next question. What is a module in Python? A module in Python is simply a file that contains Python code. That code may include variables, functions, classes, and executable statements. In simple words, a module helps us organize related code into a separate file so that it can be reused in other programs. This is very important in real-world development because large applications cannot be written in just one file. As the project grows, we divide code into modules so that each file handles a specific responsibility. For example, one module may handle database logic, another may handle utility functions, and another may handle business rules. A strong interview point is this: modules improve code reusability, readability, maintainability, and separation of concerns. Instead of copying the same code into many files, we place it in one module and import it wherever needed. Another important point is that Python provides both built-in modules and user-defined modules. Built-in modules come with Python, while user-defined modules are created by developers. You can also mention that when a module is imported, Python executes that module once and then makes its contents available for use. This is a nice interview detail because it shows understanding beyond just definition. So the complete interview answer is this: a module in Python is a file containing Python code such as functions, classes, and variables. It is used to organize related code into reusable units. Modules are important because they improve structure, reuse, and maintainability in Python applications. Next question: what is the difference between import and from import in Python? Both import and from import are used to bring code from another module into the current program, but they work in slightly different ways. When we use a normal import statement, we import the entire module. After that, we usually access functions, classes, or variables using the module name as a prefix. This makes it clear where that code came from. When we use from import, we import a specific name directly from the module. That means we can use that function, class, or variable directly without writing the module name each time. A very important interview point is readability versus convenience. Normal import is often clearer because it shows the source module in the code. From import can be shorter and more convenient, but if overused, it may create confusion about where names came from. Another strong point is namespace control. Normal import keeps the imported names inside the module namespace. From import places selected names directly into the current namespace. That can increase the chance of name conflicts if not handled carefully. You can also mention that wildcard import exists, but it is usually discouraged in production code because it reduces clarity and can pollute the namespace. So the complete interview answer is this. The difference between import and from import in Python is that import brings in the whole module and usually requires the module name as a prefix, while from import brings specific names directly into the current namespace. Import is often clearer and safer, while from import is shorter and more convenient, but can increase the chance of name conflicts. Let's take a look at the next question. What are aliases in Python imports and why are they used? Aliases in Python imports are alternate names given to imported modules or imported members. They are created using the as keyword. In simple words, an alias lets us use a shorter or more convenient name instead of the original imported name. Aliases are useful for several reasons. One reason is brevity. Some module names are long, and using a shorter alias can make the code easier to write and read. Another reason is avoiding name conflicts. If two imported modules or members have similar names, aliases help keep them separate and clear. A strong interview point is this. Aliases should improve readability, not reduce it. Using well-known aliases can make code cleaner, but using random short names can make code confusing. So aliases should be meaningful and consistent. Another good point is that aliases are heavily used in data science and scientific Python code, where some libraries are commonly imported with standard short names. Even outside that area, aliases are useful in large codebases where module names may be long or repetitive. In interviews, it is good to explain that aliases do not change the original module itself. They only change how the current file refers to that imported object. So the complete interview answer is this. Aliases in Python imports are alternate names assigned using the as keyword. They are used to shorten long names, improve readability, and avoid naming conflicts. A good developer uses aliases carefully so that the code remains clear and maintainable. Next question. What are built-in modules in Python? Built-in modules in Python are modules that come included with the Python standard library. This means we do not need to install them separately in normal situations. They are available as part of the Python language environment and provide solutions for many common programming tasks. This is a very important interview topic because Python is often described as a batteries included language. That means Python already provides many ready-to-use modules for file handling, math, dates, JSON processing, regular expressions, system interaction, random number generation, and much more. Some built-in modules are used for mathematical operations. Some are used for working with the operating system. Some are used for dates and times. Others help with collections, statistics, logging, testing, and command line argument processing. A strong interview point is this. Using built-in modules is often better than rewriting common logic from scratch. It saves time, improves reliability, and makes code more standard and maintainable. Another important point is that built-in modules are different from third-party libraries. Built-in modules come with Python itself. Third-party libraries must usually be installed separately using package managers like pip. So the complete interview answer is this. Built-in modules in Python are modules provided by the Python standard library. They offer ready-made functionality for many common tasks such as file handling, system operations, date and time work, JSON processing, and more. They are important because they let developers solve common problems without creating everything from scratch. Let's take a look at the next question. What is the difference between a module and a package in Python? This is one of the most common interview questions in Python project organization. A module is a single Python file containing code. A package is a way of organizing multiple related modules together inside a directory. In simple words, a module is one file. A package is a folder that groups multiple modules and possibly sub-packages in a structured way. This becomes very important in real-world applications because small programs may only need a few modules, but larger applications need better structure. Packages help organize code logically into sections such as services, models, utilities, controllers, and data access layers. A strong interview point is this. Packages help avoid naming conflicts and improve maintainability in large codebases. Without packages, too many modules in one place can become difficult to manage. Another important point is that historically, packages were identified using a special file to mark the directory as a package. In modern Python, package behavior is more flexible, but that traditional concept is still commonly discussed in interviews and codebases. You can also mention that packages support hierarchical organization. That means a package can contain sub-packages, and each sub-package can contain more modules. This makes Python suitable for clean large project design. So the complete interview answer is this. The difference between a module and a package in Python is that a module is a single Python file, while a package is a directory used to organize multiple related modules and sub-packages. Modules help with code reuse, and packages help with larger project structure, maintainability, and logical grouping of related code. Let's take a look at the next question. What is the difference between an iterable and an iterator in Python? This is one of the most important Python interview questions because many developers use loops daily but do not clearly understand what happens behind the scenes. An iterable is any object that can be looped over. In simple words, if Python can take values from an object one by one, that object is iterable. Common examples are list, tuples, strings, sets, dictionaries, and range objects. An iterator is the actual object that gives the next value one at a time during iteration. It keeps track of the current position and knows how to move to the next item. So the practical difference is this. An iterable is something we can iterate over. An iterator is something that performs the iteration. A very strong interview point is this. Not every iterable is an iterator. For example, a list is iterable, but it does not itself keep iteration state in the same way as an iterator object. We usually create an iterator from an iterable when iteration begins. Another important point is that for loops work automatically by converting the iterable into an iterator internally. That is why developers often use iteration without directly seeing iterator mechanics. So the complete interview answer is this. An iterable in Python is an object that can be looped over, while an iterator is the object that actually returns items one by one during iteration. Iterables provide data for iteration, and iterators manage the iteration process and current state. Next question. What is a generator in Python? A generator in Python is a special kind of iterator that produces values one at a time instead of creating and storing all values in memory at once. This is one of the most powerful and Python-specific interview topics. In simple words, a generator generates values lazily. That means it gives values only when they are needed. Because of this, generators are very memory efficient, especially when working with large data or potentially endless sequences. A normal list usually stores all its values in memory immediately. A generator does not do that. It calculates the next value only when requested during iteration. A strong interview point is this. A generator is still an iterator. This means it follows the iterator protocol and can be used directly in for loops and other iteration context. But unlike a list, once a generator is exhausted, it cannot simply restart from the beginning unless recreated. Generators are widely used in file processing, streaming large datasets, reading logs, pipeline-style transformations, and producing sequences without large memory usage. Another important point is that generators improve performance in many cases by avoiding unnecessary work until values are actually needed. This is called lazy evaluation, and it is a very good phrase to use in interviews. So the complete interview answer is this. A generator in Python is a special iterator that produces values lazily, one at a time, instead of storing all values in memory at once. It is very useful for memory-efficient processing of large or streaming data and is a key concept in Python iteration design. Let's take a look at the next question. What is the role of yield in Python? The yield keyword is what makes a function behave like a generator. When a function uses yield, it does not return all results at once like a normal function. Instead, it produces one value at a time and pauses its execution after each yielded value. This is a very important interview point. A normal return statement ends the function completely. But yield pauses the function and saves its current state. The next time the generator is asked for a value, execution continues from where it last stopped. That is what makes generators powerful. They can produce large sequences step by step without storing everything in memory. A strong interview answer should explain state preservation. When yield is used, local variables, execution position, and current context are preserved between calls. This allows the generator to continue smoothly from the previous point. Another practical point is that yield is very useful for pipelines, reading large files, processing streams, and generating computed values on demand. It is one of the cleanest ways to implement lazy data generation in Python. Interviewers also like to hear this distinction clearly. Return gives one final result and ends the function. Yield gives one result at a time and pauses the function for future continuation. So the complete interview answer is this. The role of yield in Python is to turn a function into a generator. Yield produces one value at a time, pauses the function, preserves its state, and allows execution to continue later from the same point. This makes generators memory efficient and ideal for lazy evaluation. Next question. What is the difference between a normal function and a generator function in Python? A normal function and a generator function may look similar at first, but they behave very differently. This is a very common interview question because it tests whether the candidate really understands yield and lazy evaluation. A normal function uses return to send back a result and then finishes execution completely. Once it returns, the function is done. If we call it again, it starts from the beginning like a fresh function call. A generator function uses yield instead of returning all values at once. When called, it does not run the full logic immediately and does not directly give the final data in the usual way. Instead, it returns a generator object. That generator can then produce values one at a time as iteration happens. A very strong interview point is this. A generator function preserves its execution state between yielded values, while a normal function does not. This makes generator functions ideal when data should be produced gradually. Another important difference is memory usage. A normal function that builds a full list may use much more memory if the data is large. A generator function is usually more memory efficient because it creates values on demand. A good interview answer should also mention use cases. Normal functions are good when we need an immediate final result. Generator functions are better when we want lazy evaluation, streaming, or efficient processing of large sequences. So the complete interview answer is this. The difference between a normal function and a generator function in Python is that a normal function returns a final result and finishes, while a generator function uses yield to produce values one at a time and preserves its state between outputs. Generator functions are more memory efficient for large or streaming data, while normal functions are better for direct immediate results. Let's take a look at the next question. What is a decorator in Python? A decorator in Python is a function that takes another function, adds some extra behavior to it, and returns a modified function. In simple words, a decorator allows us to extend or change the behavior of a function without modifying the original function code directly. This is one of the most powerful concepts in Python because it supports clean and reusable design. Instead of writing the same extra logic again and again inside many functions, we can place that common logic in a decorator and apply it wherever needed. For example, decorators are commonly used for logging, authentication, authorization, timing, caching, validation, and access control. This means decorators are not just theory. They are used a lot in real Python frameworks and production code. A very important interview point is this. Decorators work because functions in Python are first-class objects. That means functions can be passed as arguments, returned from other functions, and assigned to variables. Without this concept, decorators would not work in the same way. Another strong point is that the special decorator syntax with the AT symbol is mainly a clean and readable shortcut. Behind the scenes, it is still function wrapping. So the complete interview answer is this. A decorator in Python is a function that adds extra behavior to another function without changing the original function's code directly. It is widely used for reusable cross-cutting concerns like logging, validation, and access control, and it works because functions in Python are first-class objects. Next question. What is a higher order function in Python? A higher order function is a function that either accepts another function as an argument, returns a function as a result, or does both. This is an important concept in Python because it shows that functions are treated like normal values. In simple words, if a function works with other functions, it is called a higher order function. This allows Python programs to become more flexible and expressive. A very important interview point is this. Decorators are based on higher order functions. A decorator takes a function and returns another function, so it is a classic example of a higher order function. Other common examples include functions used for mapping, filtering, custom sorting, callbacks, and function factories. These patterns are useful in clean coding, functional style programming, and reusable utility design. A strong answer should also mention why this matters in practice. Higher order functions reduce repetition and make logic more reusable. Instead of hard coding behavior, we can pass behavior as input. That leads to more generic and flexible code. Another nice interview point is that Lambda functions are often used with higher order functions, although normal named functions can also be used. So the complete interview answer is this. A higher order function in Python is a function that takes another function as an argument, returns a function, or both. It is an important concept because it enables flexible and reusable code patterns such as decorators, callbacks, and functional style programming. Let's take a look at the next question. What is a list comprehension in Python? A list comprehension in Python is a concise and readable way to create a new list from an iterable. It allows us to build a list in a single expression, often with optional filtering or transformation logic. In simple words, instead of writing a full loop and manually appending values one by one, a list comprehension lets us express the same idea more compactly. That is why list comprehensions are considered very Pythonic. A very important interview point is this. A list comprehension can perform three things together. It can iterate through data, transform each item, and optionally apply a condition to include only selected values. This makes list comprehensions useful in many real-world tasks such as filtering data, converting values, extracting fields, generating derived lists, and cleaning input. A strong answer should also mention readability. List comprehensions are excellent when the logic is simple and clear. But if the logic becomes too complex or deeply nested, a normal loop may be better because readability is more important than writing everything in one line. Another good interview point is that a list comprehension creates the full list in memory immediately. So for very large data sets, a generator expression may sometimes be a better choice. So the complete interview answer is this. A list comprehension in Python is a compact way to create a new list by iterating over an iterable, optionally filtering items, and transforming values in a single expression. It is widely used because it makes simple list building logic shorter and more readable, but it should be avoided when the logic becomes too complex. Next question. What is a dictionary comprehension in Python? A dictionary comprehension is a concise way to create a new dictionary in Python using a single expression. It is similar in spirit to list comprehension, but instead of producing a list, it produces key value pairs that form a dictionary. This is useful when we want to generate dictionaries dynamically from existing data. For example, we may want to map values to their lengths, create lookup tables, transform keys or values, or filter entries from existing collections. So the complete interview answer is this. A dictionary comprehension in Python is a compact way to create a dictionary by generating key value pairs from an iterable in a single expression. It is useful for transforming, filtering, and building dictionaries dynamically, but it should be used only when the logic remains clear and readable. Let's take a look at the next question. What is a set comprehension in Python? A set comprehension is a compact way to create a set in Python using a single expression. It is similar to list comprehension, but instead of producing a list, it produces a set. That means the final result contains only unique values. This is very useful when we want to generate a collection of unique transformed values from an iterable. For example, we may want to collect unique words from text, unique lengths from strings, or unique results of some calculation. A very important interview point is this. Since a set stores only unique values, duplicates are automatically removed. Also, because sets are unordered collections, we should not rely on position or indexing in the result. A strong answer should also mention that conditions can be included in set comprehensions, just like in list and dictionary comprehensions. This makes them useful for both filtering and transformation together. Another practical point is that set comprehensions are useful when uniqueness matters more than order. If order or duplicates matter, then a list comprehension may be more appropriate. Interviewers also like candidates who can distinguish set comprehension from dictionary comprehension because both use curly braces. The difference is that a set comprehension produces single values while a dictionary comprehension produces key value pairs. So the complete interview answer is this. A set comprehension in Python is a concise way to create a set by iterating over data, optionally filtering it, and generating unique values in a single expression. It is useful when we need transformed results without duplicates, and it differs from dictionary comprehension because it produces single values instead of key value pairs. Next question. How does memory management work in Python? Memory management in Python is handled mostly automatically by the Python runtime. This means developers usually do not allocate and free memory manually in the same way as in some lower level languages. Python creates objects when needed and reclaims memory when those objects are no longer being used. This is a very important interview topic because many developers use Python comfortably, but cannot clearly explain what happens behind the scenes. When we create values such as numbers, strings, lists, dictionaries, or custom objects, Python stores them in memory as objects. Variables in Python do not directly store raw values in the simple sense. They hold references to objects. That is a very strong interview point. Python uses private memory management internally. The Python memory manager takes care of allocating space for objects, tracking them, and releasing memory when possible. Developers mainly focus on writing code, while Python handles most memory details automatically. A strong interview answer should also mention that memory management is connected to reference counting and garbage collection. Reference counting handles many objects immediately, while garbage collection helps clean up some more complex cases such as reference cycles. Another practical point is that even though Python manages memory automatically, developers still need to write memory-conscious code. Creating huge unnecessary lists, holding references longer than needed, or loading very large data sets at once can still cause memory problems. So the complete interview answer is this: memory management in Python is mostly automatic and is handled by the Python runtime. Python stores data as objects, variables hold references to those objects, and memory is managed using mechanisms like reference counting and garbage collection. This makes development easier, but developers still need to write efficient code to avoid unnecessary memory usage. Let's take a look at the next question. What is garbage collection in Python? Garbage collection in Python is the process of identifying and cleaning up objects that are no longer needed so their memory can be reused. This is very important because if unused objects remain in memory forever, the program would keep consuming more and more memory. A common interview point is this: Python primarily uses reference counting to manage memory. When an object's reference count becomes 0, Python can usually remove it immediately. But reference counting alone is not enough in every situation. The reason is circular references. Sometimes two or more objects may reference each other. Even if the program no longer needs them, their reference counts may never become 0 naturally because they are still pointing to each other. That is where garbage collection becomes especially important. Python's garbage collector helps detect and clean such unreachable cyclic objects. This is one of the strongest points to mention in interviews because it shows that you understand garbage collection is not separate from reference counting but rather supports it. Another useful point is that developers usually do not need to manually trigger garbage collection in normal applications. Python handles it automatically. But for debugging, performance tuning, or very specific workloads, developers may inspect or control garbage collection behavior. So the complete interview answer is this: garbage collection in Python is the mechanism that reclaims memory from objects that are no longer reachable or needed. Python mainly relies on reference counting, and garbage collection is especially important for cleaning cyclic references that reference counting alone cannot remove. Next question: what is the difference between shallow copy and deep copy in Python? This is one of the most common Python interview questions because it tests whether the candidate really understands mutable objects and nested structures. A shallow copy creates a new outer object, but the inner nested objects are still shared between the original and the copy. That means if the object contains other mutable objects inside it, both copies may still point to the same inner objects. A deep copy is different. It creates a completely independent copy of the object and also copies all nested objects recursively. So changes made in nested parts of the deep copy usually do not affect the original object. A very strong interview point is this. Shallow copy is often enough when the object is flat, or when inner shared references are acceptable. Deep copy is needed when we want full independence, especially in nested mutable structures. Another important point is performance and memory cost. Deep copy is usually more expensive because it duplicates the full object graph. So developers should not use deep copy unnecessarily. This topic matters a lot in real projects when working with nested list, dictionaries, configuration objects, complex data models, and reusable templates. So the complete interview answer is this. The difference between shallow copy and deep copy in Python is that a shallow copy creates a new outer object but still shares inner nested objects, while a deep copy creates a fully independent copy of both the outer object and its nested contents. Shallow copy is faster and lighter, while deep copy is safer for fully independent nested data. Let's take a look at the next question. What is the difference between mutable and immutable objects in Python? This is one of the most important Python interview questions because it affects assignment behavior, copying, function arguments, hashing, and overall program design. A mutable object is an object whose contents can be changed after creation. For example, lists, dictionaries, and sets are mutable. We can add, remove, or update their contents without creating a brand new object every time. An immutable object is an object whose contents cannot be changed after creation. For example, integers, floating point numbers, strings, tuples, bytes, and frozen sets are generally immutable. If we appear to modify such an object, Python actually creates a new object instead of changing the original one in place. A very strong interview point is this. Mutability affects reference behavior. If two variables refer to the same mutable object, a change through one variable is visible through the other. That does not happen in the same way with immutable objects because changing them creates a new object. Another important point is hashing. Immutable objects are often hashable and can be used as dictionary keys or set elements if they satisfy the hashing rules. Mutable objects like lists and dictionaries usually can't be used that way because their values can change. This topic is deeply connected to many earlier Python concepts such as strings, tuples, lists, sets, dictionaries, copying, and default argument pitfalls. So the complete interview answer is this. The difference between mutable and immutable objects in Python is that mutable objects can be changed after creation while immutable objects cannot. This affects reference sharing, copying behavior, performance patterns, and whether an object can be safely used in places like dictionary keys or set elements.